Hello everyone, today I'm going to share our current work on mechanical and mechanothermal effect of focused ultrasound at the cerebellum modulate temporal dynamics of sensorimotor processing. Ultrasound has been shown to stimulate and inhibit neuronal activity under various conditions over the last decades, using both mechanical and thermal effect of focused ultrasound neuromodulation. In our study, we targeted cerebellum, which is an integrator of multiple effector system, including affective processing, pain modulation, as well as sensorimotor processing. This previous neuroimaging study reported that noxious thermal stimuli induce activation in deep cerebellar nuclei, which is our target. Our hypothesis is that mechanical and thermal effect of focused ultrasound at deep cerebellar nucleus can modulate both non-nociceptive and thermal nociceptive sensorimotor processing. And our objective is to evaluate cerebellar sensorimotor processing under two biophysical mechanisms of FUS by comparing the temporal dynamics of evoked EMG. This figure describes our experimental setup. For the FUS parameters, we used 1 MHz fundamental frequency, pulse duration of 50 milliseconds with 50% of duty cycle. Mechanical group had 0.3 second stimulation duration for every 4.7 seconds. Stimulation duration was increased to 15 seconds in the mechanothermal group to produce thermal effect. We also estimated target brain tissue temperature rise associated with FUS stimulation using in vivo MR thermometry. No significant temperature rise was observed in the mechanical group. And in the mechanothermal group, the temperature rise was from 1 degree Celsius up to 3.3 degrees Celsius. Interestingly, 2 EMG signals were sometimes observed during a single FUS stimulation in the mechanothermal group. Our short and long latency EMG responses is a reminiscence of 2 phasic responses from mechanically sensitive polymodal C fiber nociceptive afferents, which is sensitive to both mechanical and thermal stimuli. The first response is mediated by quick C fibers, which exhibit burst activity at the onset of the stimulus, and the second response is due to slow C fibers, which is characterized as slow and sustained activity throughout the stimulation period. We suspect that our short latency EMG is mediated by quick C fibers, as the latency and the success rate is similar with the previous findings of time to peak discharge and percentage of number of afferents firing action potentials. Upper graphs are comparing the mechanical group EMG with short latency EMGs in the mechanothermal group. They're not significantly different in almost all comparisons. However, noticeably, short latency EMGs show maximum amplitude and success rate at 49 ppA, and both amplitude and success rate decrease at the higher intensity where the temperature reaches 40.3. And this is close to the temperature threshold for slow C fiber, which is 40.8. And decreased EMG activity might be the reflection of high degree phase cancellation in electrical impulses due to an increase of desynchronized conduction velocity from both quick C and slow C fibers, mediating mechanical and thermal effect of FUS. We also compare the tail movement response rate between the mechanical and mechanothermal group. Mechanical group were not able to induce any visible tail movement at the lowest intensity level. The mechanothermal group showed significantly higher tail response rate compared to that of mechanical group at the 3 upper intensity levels. We looked for possible hemorrhage and neuronal damage with H&E staining. No neuronal damage was observed in both groups at the highest intensity. We also stained the brain for visualizing neurons, astrocyte, and microglia, and measured their density and found no significant differences between the sonicated and unsonicated deep cerebellar nucleus. So in conclusion, cerebellar FUS can alter temporal dynamics of evoked EMG using mechanical and mechanothermal effect. An alteration of response latency gives information about the differential activation of mechanically sensitive polymodal C fiber nociceptive afferents. And cerebellum's capacity for basic nociceptive encoding and its relationship with the pain can be further explored with the thermal effect of FUS neuromodulation. Thank you very much for your time. And if you have any questions, I will be happy to answer them during the symposium.